So this is the last section out of chapter 12 that we're looking at, surface area and volume of spheres. Like I told you before, you do not need to memorize the formulas. I will give them to you, but you do need to be able to interpret a problem and pick the correct formula to use. Okay? So here's the formulas. Go ahead and write them down so you can use them on your homework. I will give these to you on a test. So the surface area formula is going to be the 4 pi r squared. Things to make sure you're noticing is that this is squared, whereas on the volume formula, your radius is going to be cubed. And so that's actually going to be the new bit to this lesson, is knowing how to do some stuff on your calculator with a cube instead of a square. But the volume is 4/3 pi r cubed. So you will get this formula and this formula on the board. I already kind of talked through earlier that a sphere has only one dimension that we use, and it's the radius. I may or may not give you the radius explicitly. I will at least give you enough information to find the radius, though. Okay? Another thing that I will be using in the examples is the great circle. So the great circle is the widest circle that goes right around the center of the sphere. So for an example, if I were to draw something that isn't a great circle, just so you can see what it is, it would be like me drawing a circle at the top of the globe or something. See how that still forms a circle, but it's not at the widest point? So that is not the great circle. The great circle should have the same radius as the sphere itself. So you'll notice that this radius is quite a bit smaller than the sphere's radius, right? So the key point that you want to remember is that the great circle's radius is the same as the sphere's radius. So if I give you enough information to find the radius of the great circle, you can use that radius also for your sphere. Are there any questions on what the great circle is? Okay. So for example 1, we're just going to start really basic. I'm asking you to find the surface area of the given figure. I gave you the radius straightforward, so this is one where you don't have too much to do. All you have to do is pick the correct formula. So look at the two formulas I just gave you. Which one are you plugging into? And what is the surface area?
4 pi r squared.
Good. So this would be something that you would just look at it, figure out which one you wanted, and then you're just plugging in the radius is 12. So you'll be plugging in 4 pi 12 squared. Okay? Now, as usual, I can either ask for this in terms of pi, or I can ask you to put it in your calculator and give an exact answer, yada yada. Let's just go ahead and leave this one in terms of pi. So if I leave it in terms of pi, I'm going to get 4 times 12 squared, right, are the numbers that I'm dealing with. So that will punch out to be 576 and then tack on a pi. And then that is my surface area. And I'm done. Any questions on that? All right. So that's as easy as it gets. I can bump it up a notch by, rather than just giving you the radius of the sphere directly, I can give you information so you can find the radius of the sphere and then plug it in. So I'm telling you the circumference of the great circle of a sphere is 15.5 pi. So what that means is that if I'm looking at a sphere, and let's see if I can draw this real quick. If I'm looking at a sphere and I draw the great circle is going to look like this, right? Right around the center. And I need the radius of the great sphere. Was I given the radius of the great sphere? But what was I given? So how can I find the radius if I know that the circumference is 15.5 pi? What do you know about a circumference in terms of the radius?
2 pi r.
Right. You know that a circumference is 2 times pi times the radius, right? So if I know that 2 times pi times the radius is supposed to equal 15.5 pi, can't I work backwards and find r?
Sure can.
So first things first, your pi's are going to cancel. And then how are you going to get r by itself? Yeah, here's r. So what do I still need to get rid of? The 2. So divide by 2. That's going to leave you with the radius being 7.75. Okay? Now that radius is the radius of the sphere. So now do you have enough information to find the surface area?
Yes.
What formula do you use?
4 pi r squared.
Yep, and again, that's not something you're memorizing. That's just something that you have to be able to pick out. The hardest part to this problem is understanding that you have to first go through the work to find the radius to use, right? So for this one, we've got 4 pi r squared. I'm plugging in the radius that I just found. So that's going to be 4 pi times 7.75 squared. Do you think this is one that I would ask you to leave in terms of pi or just multiply all the way out?
Multiply all the way out.
Okay, and somebody else, why do you think Brian said that we would multiply it all the way out instead of leaving it in terms of pi? Somebody different. Yep. Because I've already got a decimal involved. Yep, so if I've already got a decimal involved, I may as well just find the real number, right? So I'm going to use the pi button on my calculator. So I'm going to do 4 times second pi times 7.75 squared. And I'm going to get from that the surface area is about 754.77, about, rounded to the nearest hundredth. Any questions on how we did that? Again, the key part being that you have to be able to do this calculation, which we did back in chapter 11, actually. So this one is about a month old, that you should be able to do something like this. That if I give you a circumference or an area of a circle, you should be able to work backwards and find that radius. Okay, so now I'm asking you to find the volume. How am I going to do that? Use the second formula. But I have the radius now, right? So I'm through the hard part still. So the volume formula I gave you guys was 4/3 pi r cubed. So the tricky part to this is going to be punching it into the calculator. So you guys have got 4/3 pi and then 7.75 cubed. On the calculator, some of you guys are going to have different buttons. So doing this calculation right here on the calculator, you're looking for a few different things. You're either looking for what we call a caret key, which is going to look like, so you would type out 7.75, and then you're looking for something that looks like that. If you have a graphing calculator, it's going to be right below the clear. So you would press that and then 3 for cubed. A lot of you guys are going to have that button. Some of you guys are going to have something different. Just probably a couple of you are going to have something slightly different, and I'll just have to look at your calculator to find it. But look for something that looks like that caret key and type in 7.75 caret key cubed. That will do this calculation, and then you can just multiply that by 4 divided by 3 times pi. Okay, I'm going to put up what the answer should be so you can be checking it, and then I'm going to walk around and help anyone who doesn't see how to do that calculation. So my total calculation, hold on, is, hopefully as long as I didn't mess up, right? I'm getting to the nearest hundredth about 1,949.82 rounded, right? So see if you guys are getting that. See if you can find your caret key. I'm going to walk around and see if anyone has any questions on their calculator buttons. All right, so it looks like we're all good to go on that now. So let's take a look at the next problem. So here's the kind of problems where, you've got to interpret which formula you want to use. So I've told you that you have a leather ball, the radius is 6 inches, and I want you to estimate the amount of leather used to cover the ball. Which formula do you use?
Surface area.
Good. And so that's just one where I didn't explicitly ask you find the surface area, but I've given you the radius, I've given you everything you need, you just need to pick the correct formula, right? So for this one, yep, you guys chose correctly. We are going to be using the surface area formula, which is 4 pi r squared. And what are we plugging in for r? 6. And so since it said to estimate the amount, you know that you're going to be actually using the pi button and giving me like a decimal number, right? Rather than leaving it in terms of pi. So you can just type that string out. You can type in 4 second pi 6 squared, and you should get 452.39 about. Any questions on that?
What's your last yield?
We all good? Yeah, so that one's not too hard as long as you understand why it's surface area and not volume, right? We're covering the outside of the ball with a leather, so that's why we're using the surface area. All right, the next one. You are given clay in the shape of a cylinder. So it's like you go into a store and they've just got these rods of clay that they cut off a chunk and it's in the shape of a cylinder. Okay? And you take your piece of clay home and you mold it into a perfect ball. What is the radius of the resulting sphere? Okay, so what information do you know about this sphere? Do you know the surface area of the sphere? Or could you find the surface area? You could? Is the surface area of that cylinder going to match the surface area of the sphere once you remold it? Not necessarily. How about the volume?
Yes.
Right. So the volume of clay here doesn't change, right? When it's in the cylinder, how much volume of clay you has stays the same even if you mold it into a sphere. The surface area changes, but the amount of clay you have stays consistent, doesn't it? Okay, so can you find how much clay you have? Can you guys find how much clay you have? How can I find the volume of clay? Four. Of the cylinder. Yep, so notice that at this point we can't use the 4/3 pi r cubed because I don't have it in a sphere, right? And I don't know what the radius of the sphere is. That's what I'm trying to find. But I can use my volume formula from previous sections to find the volume of clay in the cylindrical form, right? So how do you find the volume in terms of a cylinder? What formula do we use? The base times the height, right? What is your base shape? Circle. And what is the area of that circle? Pi r squared. So in this case, pi times 2 squared, right? Times the height? 16. Remember I said the height is the distance between the two bases. So even though that isn't standing up on its end, that 16 is still the height because it's the distance between the two circles. So that's the height. I am going to leave this in terms of pi for right now because it's exact. And I might get pi's canceling out later. So I'm going to do 2 squared, which is 4, times 16 is 64 pi, right? All right, so I know that that is how much clay I have, right? And even if I remold it into the sphere, I am still going to have 64 pi as my volume. So then the question is, how can I use that volume to find the radius? Bree?
Will you plug it into the new volume area?
Yep.
Or the formula?
So I know that the volume of a sphere is 4/3 pi r cubed, right? And I just talked about, or we just decided not too long ago, that the volume of the sphere should equal the volume of the cylinder. So that's going to equal 64 pi. Are there any questions about why I can set these two things equal? Why I was able to find the volume of the cylinder and then set it equal to the volume of the sphere? Okay. So now we just have to work backwards and solve for the radius, right? So if I start solving this, the first thing I'm going to notice is that my pi's drop out, so that's nice. So at this point, I'm left with 4/3 r cubed equals 64. And we're trying to get r by itself, right? So there's a few different ways you guys can handle this. Some of you might know that you can move the entire 4/3 by doing what?
Times by 3.
So that's not moving the entire 4/3, but that's what I'm going to end up doing just to kind of break it down. But does anyone know, rather than dividing by 4/3, you can multiply by
Reciprocals?
3/4, right? So you could, and I'm just going to write it out, and then I'm going to erase it and do it kind of a way that I think more of you will like. But some of you guys might understand that you can multiply by a reciprocal, right? And it will cancel out the 4/3 on one side, but then you've got to deal with the fractions over here, right? And some of you are fine with that, so go ahead and do that if that's how you like that. I'm going to do what Brian originally said, and I am just going to multiply by 3 to start, just to get rid of the thirds, and then I'll deal with the 4 later. So I can cancel my 3's, and it's essentially the same, you're just kind of breaking it down so you can see the steps a little clearer. So I'm left with 4r cubed on one side. What's 64 times 3?
192.
Okay. And then what do you do?
Divide by 4.
So now you're going to do your division by 4. That's going to give you r cubed equals 48. Okay? And so now here's a new step. When we had r squared, what would you have done?
Square root it.
Square root it. Now that you have r cubed, what do you think you're going to do?
Cube it.
Cube root it. So that's something that I don't think you guys have seen before, but there is such thing as a cubed root. So in other words, it's the same thing as doing a square root, except for we put a little 3 right there on the root. So it's a cubed root now. So that means that I need to do a cubed root of 48. Okay, this is something new that you guys are going to have to know. So then the trick here is, how do you do that on the calculator? So on the calculator, and it depends again on what kind of calculator you have. I'm gonna put the directions up here for if you have a graphing calculator, since that's what most people have. If you have something different, I'll walk around again and help you find your button, okay? For people who have a graphing calculator, you're gonna press the math key, which I think is 3 down on the left side of your calculator. And you're gonna look for number 4. Notice that number 4 has that cubed root, right?
Enter.
So you'll press enter on that. Yep. And then on your screen, what's going to happen is you're going to have something that looks like the cubed root, and then it's going to open up a parenthesis, right? So then you're just going to type in what you want to take the cubed root of, 48, end your parenthesis, and see what you get.
R equals
Okay?
3.63.
What'd you get?
3.63.
All right, so then that would be your answer. R equals 3.63. All right. I'm going to come around and help people who don't have a graphing calculator find the correct button. So just give me 1 second. Okay, final example. So I've given you a long box that perfectly fits 2 balls that are of a radius 5 side by side. How much of the box is not occupied by the balls? So let's draw a picture of this first. Give me a second to figure this out. Okay, so let me just draw a box real fast. Hope I didn't make that one bigger. I might have accidentally. Huh? I think I kind of distorted it a little bit on the second one, but that's okay. All right, guys. Shh. Quiet, please. All right. So what I'm saying is I fit 2 spheres in here, right? Side by side. And we're saying that they fit perfectly. Whoa, not like that, that's for sure. And also not quite like that. Hold on one second. I guess I'm not very good at this. Ah! What? Nope. Good try. Well, I'm just going to draw it by hand. It's not going to be as pretty as the first one. Okay. You guys get the point. So these are spherical balls, right? So that means that they've got that kind of 3-dimensional effect going on. And they're fitting perfectly. So in other words, this ball is fitting perfectly on this edge. They touch perfectly in the middle, and then this one's fitting perfectly on this edge, and they're both fitting perfectly this way, right? There's no extra space between each ball and the walls and the top, okay? So when I ask you how much of the volume is not occupied, what am I asking you to find?
Surface area of the
Do you think it's volume or surface area? So when I ask you how much of the box is not occupied, am I asking you about how much of the edges of the box are not occupied? No, what am I asking about? The volume. I'm asking how much of that box is empty air, right? And that's talking about filling in the space, which would be the volume, right? So how do I find that volume that's not occupied by the balls? Yep, so what we want to do is find the volume of the balls and subtract them from the volume of the box. So in other words, we're going to do volume of the box, and we're going to subtract 2 volumes of the sphere, right? So in order to find the volume of the box, what do I need to know that I don't know quite yet? Do you have any numbers going on in that picture right now? No. What do you need to know about the box that you don't know?
The base and the height.
You need to know the base area. So in other words, you need to know that length and width of the base, and you also need to know the height of the box, right? How can I find all that? The radius. Okay, so my question to you is, how can I find the radius to find this? Is it 6? Why not? Okay, take a look as you move from ball to ball. Are you covering a distance of 2 radiuses when you go from ball to ball?
No.
You're covering from this ball to this ball right there. How much distance are you covering from that ball to that ball? 10, right? 2 radiuses, yeah? And then you're covering that same distance to get to the other edge. So this is 20. I don't know why I said 6 before. I think I thought that the radius was 3. Okay. You guys are probably wondering where in the world 6 was coming from. I meant to ask if it was 10. All right. What is this distance? Is that 20 again?
No.
What is it?
10.
10, because you're only covering one ball, right, which would be 1 diameter. So 10, and then how about the height? 10 again, because it's just 1 ball high, right? So when I do this calculation for the volume of the box, it's going to be 20 times 10. No. 20 times 10 for the area of the base, but then we take that times the height, which is 10. Right? We're not finding surface area, we're finding volume. Any questions on why that's the volume of the box? Okay. So that's the volume of the box, and then we're going to be subtracting 2 volumes of the spheres. Now, I will be giving you the formula, so you guys will just have to look it up. Which formula was it? 4 thirds pi r cubed, right? Yeah, you need to be using the volume formula, not the surface area. And that's, since I'm giving you guys the formulas, that is going to be the biggest thing, is that are you choosing the correct formula to use? Now, instead of putting in r, I can put in 5, right? All right, so what is 20 times 10 times 10?
2,000.
2,000. And then you guys need to be calculating this thing over here, right? So minus 2 times, what I want you to do is just calculate what's the volume of one sphere real quick. You guys should be able to do that now that I've shown you all of your keys. Let's see if you can use that cube key correctly. Okay, so you should have gotten that the volume of one sphere was 523.5987 about, right? What?
I thought we were supposed to round
Stop, round to the what?
up. Round up to the next.
When you're doing the 4 decimal places, you can round or you don't have to round. I make you do 4 decimals so that that last digit doesn't affect your final answer. If you were to only do 2 and then not round, it would really affect your answer. But so he was asking, why didn't I round up on the 7 and make that an 8? And it's just because that digit in the end shouldn't affect too much. All right, so now we do 2,000 minus 2 of those, right? So I do 2,000 minus 2 times my 523.5987. What do you guys get?
952.8025.
And I'll just go ahead and do 80 for that since we're at our final answer. So this is how much of the box is unoccupied in terms of volume. Are there any questions on that? No? All right. So you will notice that this assignment is optional. It's because I'm giving you your review packet and I've given you practice problems for this section in the review packet. And I don't want you guys to go home and spend your whole time on just 12.6 when you have a whole bunch of other things you need to know as well. So basically do the review packet first. And if you, what?
Is this like extra?
No, this is just if you do the review packet and you get through the volume problems for the sphere surface area, what did I just say? The surface area and volume for a sphere, and you do those problems and you're not super comfortable with them, and you want more practice before the test, then you can do this assignment. It's odd, so you can check your answers in the back of the book. Okay? So you can do that if you get through the review packet and you still don't really get the sphere stuff. But the review packet should be first and foremost because the quest has a bunch of other material as well. All right? So let's pass out those, and we'll spend the rest of the hour working on review.